In this video, let us discuss about circles and tangents. How many tangents can be drawn to a circle from a point? Now, let the point P be inside the circle. Draw a line through it, another line, another line. All of these are not tangents, they are only secants. So, no tangents can be drawn to a circle from a point inside the circle. Now let us take a point P on the circle. Through it, one and only one tangent can be drawn. Now take point P outside the circle. Through it, two tangents can be drawn. So two tangents can be drawn from an external point to a circle. Length of the tangent. The length of the segment of the tangent from the external point P and the point of contact with the circle is called length of the tangent from the point P to the circle. Now the point of contact here BT1, this BT2. So now PT1 and PT2 are the length of the tangent from P to the circle, and PT1 is equal to PT2. So let us check. This is the length of the PT1, which is equal to PT2. So now we can have PT1 is equal to PT2. So now we have seen that lengths of the tangents drawn from an external point to a circle are equal. This is an important theorem in the chapter circles. This question is frequently asked in the exam. In almost every exam, this question has been asked. The question is, prove that the lengths of the tangents drawn from an external point to a circle are equal. What is given here? What is data here? A circle with center O. And PQ and PR are the tangents. P is the external point. From P, we have two tangents. That is PQ and PR. To prove PQ is equal to PR, that means the tangents are equal in length. Let us do one construction. What is that? Join OP, OQ and OR. Now we have two triangles, triangle PQO and triangle PRO. So in triangle PQO and PRO, angle PQO is equal to angle PRO is equal to 90 degree. Why they are 90 degree? At the point we are just now in the previous lesson we have learned that at the point of contact radius and tangents are perpendicular, isn't it? So now we can say that both the triangles are right angle triangles. Now let us write R here. One side is common to both triangles. What is it? OP is common. It is hypotenuse to both triangles. So now let us write H here. And still one pair of sides are equal to each other. They are the radii of the same circle. OQ is equal to OR by radii of the same circle. This is one side. So because of RHS congruency rule, the triangles are congruent. So now we can write that triangle PQO is congruent to triangle PRO because of RHS rule, right angle hypotenuse side rule. So, due to corresponding parts of congruent triangles, now we can say that PQ is equal to PR because of CPCT, corresponding parts of congruent triangles. Hence, the theorem is proved. Now, in triangle, we have proved that triangle PQO is congruent to triangle PRO, isn't it? So, their corresponding sides are equal. We have already shown that PQ is equal to PR. We can also say that because of corresponding parts of congruent triangles. Now, angle QPO is equal to angle RPO because of same criterion, congruent parts of congruent triangles. And we can also say that angle QOP is equal to angle POR. See the figure, you can understand more properly because of congruent parts of congruent triangles. This is not included in that theorem, but I have extended this one in order to solve multiple choice questions. Here QPRO, observe the quadrilateral. We know that sum of all the angles of a quadrilateral is 360 degree. We already know that angle Q and angle R are equal to one another and is equal to 90 degree. So angle QPO plus angle PRO is equal to 90 plus 90, 180 degree. The other two angles remaining in the quadrilateral are QOR and angle QPR. Sum of these angles is also is equal to 180. So now we can say that angle between the tangents, this angle, and angle between the radii are supplementary to each other. This is also one important concept. Now let us solve some of the exam questions based on this concept. In the following figure, PA, PC, CD are the tangents drawn to a circle of center O. If AP is 3 cm, CD is 5 cm, then the length of PC is. 4 options are given. They are option A 3 cm, option B 5 cm, option C 8 cm, option D 2 cm. If you are clever enough, you can readily tell the option C is correct. How? Here observe, CD and CB are the tangents drawn from the external point C. So CD is equal to CB, that is 5 cm, and PA and PB are the tangents drawn from the external point P. So PA is equal to PB, PB is equal to 3 cm. PC is equal to PB plus CB, so 5 plus 3, that is 8 cm. So option C is correct. In the figure, PA and PB are two tangents drawn from an external point P to a circle with center C and radius 4 cm. If PA is perpendicular to PB, then the length of each tangent is. 4 options are given: A 5 cm, B 3 cm, C 4 cm, D 8 cm. Here it is given that radius CA or CB is 4 cm and this is perpendicular 90 degree. So angle between the radii is also 90 degree, since angle between the radii and the angle between the tangents are supplementary. 90 plus 90, 180 degree. This is also 90 degree. This angle is also 90 degree, since tangent and radius are perpendicular to each other at the point of contact. Since all the angles are 90 degree and the two adjacent sides are 4 centimeter, then tangents are also, all sides are equal. So length of each tangent is 4 centimeter. So option C is correct. In the given figure, if OQ is equal to 3 centimeter, OP is equal to 5 centimeter, then the length of PR is 4 options are given. Option A 4 centimeter, option B 3 centimeters, option C 5 centimeter, option D 6 centimeter. Here PR is equal to PQ. Why? Tangents drawn from the external points are equal. It is drawn from the point P. We can calculate PQ by using Pythagorean theorem, because here angle Q is 90 degrees, since radius and tangents are perpendicular to each other at the point of contact. So PQ is equal to 5 square minus 3 square. Square root of 5 square minus 3 square, that is equal to 25 minus 9, that is equal to square root of 16, that is equal to 4. So PQ is equal to 4, PR also is equal to 4 centimeter. So option A is correct. The length of the tangent drawn to a circle from point Q is 24 centimeter. The length between the point Q and the center of the circle is 25 centimeter. We are not given figure, so now let us have it. The length of the tangent is 24 centimeter. The length between the point Q and the center is 25 centimeter. And we have to find the radius. We know that angle between the radius and the tangent at the point of contact is always 90 degree. Let this point be P. This problem is similar to the previous one. This is a right angle triangle. OPQ is a right angle triangle. So we can use Pythagoras theorem to solve it. So OP is equal to square root of 25 square minus 24 square. If it is 2 marks question, you have to explain each and every steps. This is MCQ. We can scribble or do mental mathematics, whatever you want, you can do. By using the formula identity A plus B into A minus B, that is equal to A square minus B square. So square root of 25 plus 24 into 25 minus 24, that is equal to 49 into 1, that is equal to square root of 49, that is equal to 7. So OP is equal to 7 centimeter. So radius of the circle is 7 centimeter. Option A is correct. A tangent is drawn from a point 13 cm away from the center of the circle whose radius is 5 cm. Then the length of tangents is, 4 options are given. Option A 3 cm, option B 8 cm, option C 12 cm, option D 17 cm. If you can visualize the picture properly, you can readily answer. The correct option is C. Option C is the correct option. By using Pythagorean triplets, you can say that 5, 12, 13 are the Pythagorean triplets, and the problem is similar to the previous ones. Okay, now let us have the figure. This is the line joining the center and the external point, which is 13 centimeter. This is radius, which is 5 centimeter. Let this point be P. Now square root of 13 square minus 5 square, because it is a right angle triangle, that is equal to 169 minus 25, that is equal to 144, root of 144, which is equal to 12 centimeter. So option C is correct. In the figure, TP and TQ are the tangent to a circle with center O. If angle POQ is 110 degree, then PTQ is equal to. Four options are given. Option A 60 degree, option B 70 degree, option C 80 degree, option D 90 degree. We know that these two angles, means angle between the tangents and angle between the radii, are supplementary. Means sum of these two is 180 degree. So 180 minus 110. What is it? 70 degree. So option B is correct. In the figure, angle APO is 50 degree. Then angle BOP is. We know that triangles APO and BPO are congruent to each other. So angle OPB is for 50 degree. This is 90 degree. So angle BOP and angle PBO are complementary to each other, and their sum is equal to 90 degree. 90 minus 50. What is it? 40 degree. So this angle is 40 degree. Option A is correct. In the figure, a circle touches the side DF of triangle EDF at H and touches ED and EF produced at K and M respectively. If EK is 9 centimeter, that is the tangent. Observe, this is 9 centimeter. Then the perimeter of triangle EDF is. Perimeter of triangle EDF is equal to ED plus DH plus HF plus FE. Let us replace DH by DK. Why? They are the tangents from the external point D. HF by FM. Why? They are the tangents from the external point F. ED plus DK is equal to EK. FM plus FE is equal to EM. Observe that EK and EM are the tangents from the external point. So this is equal to 2EK. That is equal to 2 into 9, that is 18. So the correct option is 18 centimeter. Now onwards, you can use the trick that if you are asked this type of question, you can directly multiply the length of tangents by 2, and which is the perimeter of this type of triangle. If you are given the perimeter of the triangle, then you do half of it, then you will get length of the tangents. That's all. That's all. So option B is correct. In the figure, perimeter of triangle ADE is 20 centimeter. Then the length of AB plus AC is. This is AB, this is AC, which are the tangents. Perimeter of triangle ADE means AD plus DP plus PE plus AE. We can replace DP by BD. So AD plus DB is AB. Similarly, we can replace PE by EC. EC plus EA is equal to AC. So perimeter of triangle ADE is itself AB plus AC. So option A is correct. In the figure, perimeter of triangle ADE is 20 centimeter. Then the length of AB is the tangent. We have already learned that half the perimeter of triangle is the length of the tangent, isn't it? So option B, 10 centimeter is correct option. But still, let us do it once again. Here perimeter of triangle ADE is equal to AD plus DP plus PE plus EA. Here DP can be replaced by BD. Why? You know they are the tangents from the external point D. PE can be replaced by EC. Why? They are the tangents from the external point E. So, perimeter of the triangle ADE is equal to AD plus BD plus EC plus EA. Here you can observe that AD plus BD is equal to AB. EC plus EA is equal to AC. Here we have to find the length of AB. Here AC is equal to AB. Why? They are the tangents from the external point A. So perimeter 20 centimeter is equal to 2AB. So AB is equal to 10 centimeter. So option B, 10 centimeter is correct.